Okay, I think we are going to start. Thank you for coming to my talk. My name is Amr Awadallah, as you can see up on the screen. And I am the co-founder and the chief technical officer for Cloudera. Today, I will be talking about two things. First, I will tell you why we are all here in this room. It is something that I refer to as the sixth wave of automation that human civilization ever experienced. So I will tell you about the previous 5 waves, so we can truly respect the value of this sixth wave. And then I will talk about the role that we need to play to enable that sixth play, not just that sixth wave, not just Cloudera, but all of us together. I will describe briefly our platform to you, the Cloudera platform, and we'll give you examples of how some of our customers are using us to enable the sixth wave. So start telling you the story of the 6 waves. This is the belief and the mission that we have at Cloudera. We believe that data, when leveraged and used correctly, will enable us to solve problems in the future that are impossible to solve today. So one example of these problems is this slide picture you see on the right side, which is we are working with NASA using our platform to get humans to go to Mars and hopefully come back as well. So that problem that 10, 20 years ago we would have totally thought was impossible to do or achieve, but now through many technological advancements, but more specifically through our ability to leverage data, we are able to do. So the story starts 100,000 years ago. 100,000 years ago, we had the first wave of automation, wave number 1. Wave number 1 was the automation of knowledge transfer. The automation of knowledge transfer, which is a very fancy way of saying talking. We figured out how to talk as a human species, and that was the beginning. All other species like gorillas, lions, giraffes, dolphins, you name it, they relied on their DNA to pass information. They had to wait for their DNA to encode that touching fire is a bad thing before their kids stopped touching fire. While we humans, we were able to just tell our kids, stop touching fire, it's bad for you. Now, many of them still touch the fire, but that's a whole other phenomena of disobeying your parents. The key point is the information and knowledge could be transferred way quicker than ever before, and this put us on a evolutionary trajectory way quicker than any other species. That was wave number 1, 100,000 years ago. It shows you how lucky we are to be here today in this room. 10,000 years ago was wave number 2. Wave number 2 was the automation of food. The automation of food. As you know, before wave number 2, all of us, we were hunter-gatherers. We wake up and we spend 16 hours per day, if not longer, looking for food, just so we can eat, sleep, wake up, and do the thing again. We had no time to think. We had no time to have fun. That was all we had time for. And then a bunch of very smart people, they eventually were called farmers, figured out that using the ebbs and flows of rivers, we could grow food at much higher rates than ever before. And that had 3 implications. The first implication, which is a common theme that you will see over and over again, is everybody who was a hunter-gatherer lost their job. They lost their job. But that was good. That was because they learned now a much more and adapted to a much more productive job. Number 2, the second implication was we had a lot more food and we had a lot more time, so we started having a lot more children. So our civilization growth really started with that wave. And number 3, which probably is the most important implication of this wave, we had a lot more time to think about higher level concepts. The other important thing that happened with this wave that many historians will tell you is we also figured out cooking, And cooking food with fire allowed our brain to evolve the ability to think about higher level concepts much quicker as well. So that was wave number 2. Wave number 3 is the automation of discovery. The automation of discovery. How can we discover new concepts around us much quicker? And this happened around 3,000 years ago, plus or minus 1,000 years. Each one of these waves took very long times compared to the waves we have right today. And by this, we mean the principles of mathematics and science and physics and chemistry and so on. That was wave number 3. And now we're getting much closer to our timeline. Wave number 4 happened around 200, 300 years ago. And that was the automation of making and moving stuff, which you all are familiar to as the Industrial Revolution. The Industrial Revolution. We learned how using steam engines and eventually gas and electrical engines that we can make things and move things way quicker than ever before. Today, we almost never make cloth by hand, right? Back then, we were making cloth by hand. And just as I mentioned earlier, everybody whose job was to make cloth by hand lost their job. But we adapted as a civilization, and there is no question that the Industrial Revolution was one of the most important waves of automation in terms of expanding. The mic is having issues. Expanding our throughput, economic and production capacity as a human civilization. So that was wave number 4. Wave number 5, I refer to as the automation of processes, which is more commonly known as the information technology revolution. It started about 78. You want to check the mic quickly? Change it? So hopefully the new mic is better with less interference. I also took my cell phone out of my pocket in case that was the reason. But if you think about this wave, the information technology wave, it wasn't about doing anything new per se. It was about taking an existing process and then performing that process much quicker, much more accurately and reliably using computers and networking. For example, when you apply to open a bank account, in the old days we had to fill a form by hand and then it had to be filed in a drawer somewhere, and now it all happens with these computers. Or the way I like to describe it to my kids so they truly appreciate that wave is before this wave we had to write a letter with hand and write words and stuff with our hand and put it in an envelope and actually write an address with our hand and put a stamp, and now you just send a Snapchat with a picture in it, right? It's the exact same process. It's just happening way quicker because of that wave. Now, I want to get a show of hands from you. How many of you saw a movie that came out last year called Hidden Figures? Hidden Figures. Please raise your hand. So about 40% of the room. For the remaining 60%, I urge you to please go watch that movie. It's actually a very good movie. It handles a number of very important topics, of which this is one of them, but also handles racism as well. But one of the fun facts that we learn about in that movie is that the word computer was the name of a job, just like accountant or lawyer or engineer or etc., or doctor, etc., etc. The word computer was the name of a job. Now we don't even remember that, and very few. I didn't even know that myself. And these computer people were hired to do computation, to add and subtract very quickly, but also solve differential equations, to do forecasting of revenues or detection of fraud, or in this movie, Hidden Figures, they were doing the analysis for the trajectory for launching rockets into outer space with NASA. Everybody who had a job of computer lost their job. The computer became, the machine became their job. Yet we adapted, and one of the nice things you see in the movie, how these computer humans learn to adapt to be the masters of the machine computer. And this brings us to the wave number 6, which is the wave I really want to talk about, which is the rest of this talk, which I refer to as automation of decisions. I hate the term AI, artificial intelligence. I hate the term because it's not about replicating intelligence in any way, shape, or form. Not even close to doing that. And it just sends the wrong message and it confuses people. What it is about, it's about collecting data around how we as humans perform certain tasks or make certain decisions, and then leverage that data, hence big data, to solve and repeat these decisions in more reliable ways. But it's not about recreating intelligence. One of the examples I like to always use is to illustrate that. I'm sure many of you are familiar with deep learning and neural networks. You have to feed them massive amounts of data to learn to do a single task. I can show a 2-year-old the picture of a banana, and they will learn immediately how to tell a banana from a watermelon or from something else. I have to show machine learning algorithms, deep learning algorithms, 100,000 bananas before they learn. Now, once they learn that specific task, they actually become better at it than us, right? So facial recognition, we as humans, we can only tell apart maybe 1,000, 2,000 faces and link them back to their names. With machines, because of the amount of memory available and the amount of computation available, they can do facial recognition at a scale that a single human could never achieve. And that's kind of what this movement is really about. Specific tasks. It's not about intelligence at all. One of my most favorite examples that I always like to use is from JP Morgan. JP Morgan is one of our largest customers, and they have been with us for many years. And this example is one of my favorite examples, and sorry for the lawyers in the room, but they were able to replace lawyers, not entirely, but for certain tasks with this technology. So they signed all of these legal contracts with many, many partners. They collected the input and the output legal contracts from the last 20, 30 years, analyzed them to figure out the patterns that the lawyers typically do in terms of rewriting the clauses in these contracts. And they were able to replace, for new incoming workloads, they were able to replace 400,000 lawyer hours with 10 minutes of computer time. Now, the lawyers still get invoked. The computer will still say, a lawyer needs to look at this clause when it's something that's truly sophisticated, that's no longer mundane. And this is really the level of automation that we're talking about. It's augmenting us for the mundane tasks. We at Cloudera built a support engineer AI. I'm using the term AI because it's easier for people to understand what I mean, despite me hitting the term. And the support engineer AI looks at the data that we collect from our customers, from the clusters and how they're using it, and not only can diagnose problems that they have and tell them how to fix these problems, it can predict problems. It can predict that 2 weeks from now, given this pattern, from what I've seen from other customers working with Cloudera, this customer will have a failure if they don't go and change this configuration or change this server or change this networking topology, et cetera, et cetera. Indeed, today, 30%, between 20 to 30% of the customer support workload that Cloudera does for our customers is done in a fully automated way with machines. These are just a couple of examples, and I will give you more examples as we move on. But this is it. This is wave number 6. Wave number 6. The reason why we're all here in this room today and what we are trying to enable is this, is how can we collect data around how humans make decisions and then automate that as much as we can. For the BI folks in the room, please raise your hand if you consider yourself in the BI industry, business intelligence industry. Please raise your hand. About 20% of the people in the room. The difference between the previous wave of BI and the new wave of BI, the previous wave of BI, we generated a dashboard or a report that a human looked at to make a decision. The new wave of BI, we learn how that human made a decision based on that dashboard and report, and we automate that decision. So that's another analogy to describe what's happening here. Now, a question that I get frequently asked is, why is this happening now? Why didn't this happen 5 years ago? Sorry, 20 years ago, 30 years ago? And the reason why is we needed this inflection point to take place, this intersection point of these two curves, the white curve and the red curve. We need that to take place. Machine learning algorithms that we're using today, including deep learning and neural networks, they were available to us 40, 50 years ago. They're not new. We had them a very long time ago. But what we did not have is the amount of data required to be able to teach them. And today, because of mobile networks, because of sensor networks, because of many of our businesses already are instrumented digitally, we're able to collect much larger amounts of data that are required to feed these algorithms. So that's the red curve that you see here. And then the white curve is the cost of the compute. It was very expensive to run these algorithms. It required to buy a supercomputer to be able to do it. So only weather agencies and military organizations were able to afford to do things like this, or space agencies. But now, thanks to Google publishing the genesis of the big data revolution, MapReduce, and the Google file system, which in a nutshell is divide and conquer, how divide and conquer big problems over a large number of industry standard economical servers, the cost of compute dropped so quick over the last 50 years for these type of problems. Couple that with AWS and Azure and others launching cloud environments that let me say, in a cloud environment, I want to get 1,000 servers for the next 5 hours to run my algorithm. That wasn't even thinkable 10 years ago. You had to, no, we couldn't go and buy 10,000 servers and instrument them in a data center. We just couldn't do it fast enough. Now we can ask for them and get them within seconds. That's why this is happening today. So at Cloudera, what we do, I'm a bit biased because I'm one of the founders, we deliver the best modern platform for enabling machine learning and analytics optimized for cloud environments. The two key functional areas that we focus on are machine learning and analytics, meaning BI, SQL, and so on. But we do it in this form factor, which I refer to this form factor as the smartphone of big data. And this is where I ask you to answer the question, why over the last 8 years you shifted 90%, if not 100% of your photo-taking behavior to be with the camera on the smartphone versus a real camera? Just think about that question. And while you're thinking, I'm actually going to do a panorama picture of you that I will post on my social media, so hide your face if you don't want to be in it. So why, over the last 8 years, you shifted 90 to 100% of your picture-taking behavior to be on a device like this versus an SLR camera that, by the way, could take much better pictures back then. Today, maybe not so much, but back then, it took way better pictures, and yet we still shifted. The first answer that I'm guessing 80% of you is thinking, which is correct, but it's not the answer I'm looking for, is the convenience of having it with me all the time. But we had compact cameras that were with us all the time, and yet we still shifted. The true power is the convenience of once I capture that picture, once I capture that data, I can act on it right away. I don't have to take out the flashcard, copy the data with a cable or whatever before I can start acting. I can capture and act. And this is exactly the same thing that we want to enable for the enterprise. I call it the smartphone of big data. How can I collect data? And once I collect that data, I can do data science on it, I can do SQL on it, and analytics, I can search it, I can do batch processing right away. Unlike how we do it today in most organizations, what we do is, if you want to do data science, you have to copy the data to your data science platform. If you want to do BI, you copy your data to the BI platform. If you want to do search, you copy your data again to the search platform, the same data, over and over again, which leads to a lot of friction, makes it very hard to be agile as an organization, and leads to metadata chaos, where it becomes very hard to govern the duplicates of the data and what it really means. So we solved that problem at Cloudera, and this is one of our unique differentiators compared to our competitors by this layer called SDX, Shared Data Experience. And Shared Data Experience is essentially the layer that allows us to have a common security, governance, workload management, ingest and replication layer to coordinate all of these different workloads. so you don't have to copy your data over and over again. And you can attack your data sometimes with data engineering or SQL or data science without having to move it over and over again. That's our true power, actually, at Cloudera, and the core asset behind our platform that makes it the best platform for being innovative and agile. And we have that platform work with different kinds of storage. So you can have, for on-premise, inside of your organization's data centers, we have our own storage solutions we provide, like HDFS, Kudu. We also work with EMC Isilon, if you have EMC Isilon. And then in the cloud, we work very tightly with Microsoft Azure Data Lake Store, ADLS, or Amazon S3, providing this same SDX functionality of unified security, governance, workload management, and shared metadata catalog across all of these storage environments. I frequently get asked to bubble down what machine learning really means. And machine learning bubbles down to many, many things. But when we surveyed our customers, 3 things came up 90% of the time, over and over again, in terms of what they're doing when they say machine learning. And these are the 3 things. The first one is pattern recognition, detecting patterns of behavior of your customers or products. The second one is anomaly detection, detecting weird stuff, detecting the needle in the haystack. And the third one is predictive analytics, predicting the future as a function of the past. 90% of machine learning applications fall into one or all 3 of these categories at the same time. Deep learning and neural networks is coming up. It's not there yet. It's mainly being used for voice, translation, and image processing applications and video processing applications. But you look at customer 360 products, optimization applications, most of them all fall into one of these 3 categories. So very briefly, the first one, pattern recognition, enables one of the core shifts in the industry to what I refer to as clustering versus segmentation. Clustering versus segmentation. In the old days, because we didn't have systems at scale, we came up with a hack called segmentation. We will segment our users as married with children, without children, this age group, living here, this income level. We will map all of our customers into one of these segments and then do our targeting, our fraud based on these segments. That was one of the worst hacks we ever done in the IT industry because it leads to false positives, a lot of false positives. One of the most famous false positives that I'm sure many of you are aware of, if you are the best driver in the world, you are the most behaved, best driver in the world, but you are driving a red car, because you're driving a red car, you will have higher insurance. And this is an example of segmentation leading to a bad outcome, a false positive. The new way of doing it, the pattern recognition way of doing it, is no, I am going to collect data around the behavior of my customers, and I will use clustering techniques like k-means clustering, and there's many others, to organically reveal the behavioral clusters, as opposed to these fake ones that we have created with segmentation. So that's a very common trend in the industry, and it's the most common use of our platform. It's called Know Your Customer or Customer 360. Anomaly detection, as you can see, it's mainly being used for finding the needle in the haystack, very useful for cybersecurity, fraud detection, anti-money laundering, anything where you're trying to find weird patterns and weird stuff. And then last but not least, predictive analytics is about predicting the future as a function of the past. And I will conclude by showing you a video that shows that from one of our mining customers. It's a customer that makes manufactures big machines for mining and drilling tunnels. And I never thought they would be an AI/big data customer, but you will see their use case in the conclusion. So very quickly, a couple of announcements from us that we introduced into the market over the last few months. One of them is this platform that we call the Cloudera Data Science Workbench. Cloudera Data Science Workbench is about making it easier for data scientists to innovate and work with the administrators of clusters, balancing the requirements for trying out new algorithms with stability and security, which is a very hard problem. How do you take a data science algorithm from inception and innovation into production? Many of you, I'm sure, have suffered with that and how long that can take as a process. And this product is about shortcutting and making that feedback loop much quicker So if you want to learn more about Data Science Workbench, I invite you to come to our booth here at the conference, and we can tell you a lot more about it. Second is we acquired a company called Fast Forward Labs, which is a research firm that produces a publication every few months about how to use the latest and greatest machine learning AI technologies from academia in practical business ways. So it describes the algorithm, it describes how you can implement it, includes sample code for how to implement it. Hilary Mason, very well-renowned data scientist, she is the founder of that company, and she's now part of the Cloudera team with her team of data scientists producing this very, very rich content that we make available to you. Again, come to our booth to learn more how to get access to it. And then the last key announcement is we launched this year a new suite of products that's called Cloudera Altus. Cloudera Altus is our cloud above the clouds. It's our platform running as a cloud service. Today, it supports Azure and AWS. Makes it very easy to move workloads between on-premise and any one of these cloud environments. So this SDX, Shared Data Experience functionality I described earlier with catalogs and so on, allows you to maintain that security and metadata across any of the cloud environments and on-premise. So it makes it much more easier to move things around and scale up and scale down, which is the main benefit of the cloud. So I will unfortunately skip this slide. You can take a picture of it if you want, but this is some of the key advice that we give about how to evolve your organization to be a data science / big data organization. Now I want to conclude by bragging a bit. I want to brag about the large number of customers that we have across the world in many, many industries. When we started Cloudera, we thought big data and data science would only be useful for internet companies, but history has proved that to be wrong. This is applicable across every single industry you could think of. We have agriculture customers using our platform today, manufacturing customers like the one I'm going to show you next. 7 of the top 10 world banks are customers. 9 of the top 10 global telecom companies are customers. British Telecom, for example, is one of our key customers. Vodafone, another one. 29 government organizations use us for taxes and analytics around taxes and how to collect taxes, which is big data can play a very big role in that, et cetera, et cetera. So now, without further ado, I will show you a short video, and that will be the ending of my presentation. Can we have the audio play, please?
We are a global manufacturer of large-scale mining equipment. Our customers include the largest mining houses, and they deliver the resources that the global economy needs to function. We see that engaging with our customers in a service offering based around really the Internet of Things and analytics based on data coming from our machines is a way for us to help our customers use that equipment more effectively.
We really had a goal that we wanted to be able to connect all our equipment. Cloudera really offers us the ability to scale and grow incrementally and to do it actually faster and better.
We have a team based out of Queensland in Australia who monitor and optimise a couple of longwall mines. We're able to bring all that data together in one place and analyse it to understand the full picture of the operation of that mine and make recommendations to the customer that have ultimately resulted in a doubling of the production hours.
Definitely machine learning algorithms are important, and I think for a long time it was hard to do that because our data was all in different silos, and now we have one single environment in Azure that's able to deliver all of the data for all of our customers. It's all in one place, and we can actually get to it, and we can run learning algorithms on it much more effectively.
The Cloudera platform has freed us from making decisions based on what our infrastructure can support to making decisions based on what our customers' true needs are.
So this is one of my, there's an echo going on, oh, because I'm too close here. This is one of my most favorite examples because of two things. First, it's a manufacturing company, right? It's one of the organizations that we thought would never be deploying and using this technology. But second, it's because they are doing exactly what I started my talk about. they are automating decisions. They are looking at how their support engineers were going into the field to maintain these heavy equipments and optimize them to have better performance. And now they're doing predictive maintenance, predicting when something will fail, only maintaining it when it's about to fail, as opposed to overly maintaining it, which is very expensive and causes downtime. And second, they're doing what's called dynamic optimization. They're continuously optimizing the performance parameters of these equipment to enable their customers to be much more productive. So it's true automation of decisions, in my opinion. So with that, I conclude my talk. I thank you very much for being here today and invite you to be part of the automation of decisions wave. Thank you.